Hello everybody, it's Miss Wiley, and today I'm going to be talking about factoring trinomials when a does not equal 1. I have another video that demonstrates the method of guess and check. This video will be a different method, but I'm going to do the same exact problems. Okay, so let's get right into it. So first thing I'm going to do is I'm going to talk a little bit about the form of ax squared plus bx plus c. It is important to understand that a is the coefficient of x squared, b is the coefficient of x, and c is the constant value that does not have a variable. The problems that we will do today will have an a value that does not equal 1. When we do these problems, it will still factor into two binomials, but we are going to use a different method to factor. We are going to use what's called the grouping method, which I will go over it step by step. Before we do that, let's do an example of multiplying two binomials together. When we multiply two binomials together, we start with the first terms giving us 2x squared, and then multiplying the 2x to the 3, that gives me the 6x. Multiplying the 1 times the x, that gives me 1x. We also need to multiply the 1 to the 3, that gives me the 3. The next thing that we do is we combine like terms. That's these two terms right here. When we combine them, we get an answer of 2x squared plus 7x plus 3. This is what we call the simplified form. So this is the simplified form. This is what we call the factored form. And what we are going to be doing today is we're going to be working backwards. I'm going to show you how to get from this step to this step and how to go from this step to this step. The way that I'm going to show you how to do this is using what's called the grouping method. Now, Okay, so let's look at this first example here. I'm going to show you how to do this problem using the grouping method. One thing that we are still going to be using in this problem is that sum product method that we used before. We're just going to use it a little bit differently. Okay, so our goal here is to take this and to break it up into 4 terms. So we have to figure out how to split up this 7x term into 6x and 1x. So the way that you do that using the sum product method, okay, is you are going to first figure out two numbers that have a product of the a times c value and have a sum of the b value. So in our problem here, the value of a is 2, the value of c is 3, which is 6, and then the value of b is 7. So we are looking for two numbers that have a product of 6 and a sum of 7. The ways that you multiply the 6 would be 6 times 1 and 2 times 3. So absolutely, it's not going to be this. It's going to be this one here. Okay, so that's what we're going to use to help us split up 7x. So what we're going to do is we are going to first take the 7x and we're going to split it up using the 6 and the 1. So that means we're going to split it up as a 6x and a 1x, because when we add those together, it'll give us 7x. So this is going to be plus 6x. This is going to be plus 1x. Okay, I'm going to erase that because we don't need it. And then what you're going to do with this number here and this number here, or this term here and this term here, is we're going to bring it down to the next step. I'm going to write this a little bit bigger for you. So I'm going to bring this down to the next step. I'm going to bring this down to the next step. And you can see, voila, there are our 4 terms that we had up here when we did our multiple distribution or FOIL method on the 2 binomials. So let's talk about how we get this to be 2 binomials. This is where the grouping method comes into play. Okay? So for the grouping method, the first thing that you're going to do is you're going to group the terms. When we group the terms, we literally take the first 2 terms, put them in a parenthesis, and we take the second 2 terms, and we put it in a parenthesis. We do need to make sure that we put a plus sign in between our 2 groups. There should always be a plus sign in between, never a minus sign. So I'm going to make a little note that you want plus sign between. Okay? The next thing that we're going to do is we are going to factor out GCFs. So from each of the groups, we're going to look for a GCF. So looking at the first group, the GCF you should see is a 2x. You're going to take that 2x, you're going to write it on the outside of the parenthesis. GCFs never disappear when factoring. So we write on the outside, we divide to get what's left. You can definitely do this division in your head. So it leaves me with x plus 3, and I'm going to bring down my plus sign. Now I'm going to look for the GCF in the second parenthesis. In the second parenthesis, the only GCF that I have would be a 1, because 1x and 3, the only thing they have in common is a 1. So I'm going to factor out a 1. If you divide something by 1, you're not going to get anything that changes. The only thing I'm going to do differently is write the 1x as just an x. So it's still x plus 3. If you do not put this 1 here on the outside, it will mess you up later. When you are using factor by grouping, you should always factor out some kind of GCF, even if that GCF is just a positive 1 or maybe even just a negative 1. Okay, at this point of the problem, what should happen is you should be left with 2 parentheses in your expression that are exactly the same. Basically, what that means is you have yet another common factor. So I'm going to take out that common parenthesis. Okay, so you're going to factor out the common parenthesis, which will be the x plus 3. And then if you took this out, so imagine you took this away and took this away because you factored it out to the front, what would you have left inside? So if you cover those up, so let me erase them. Taking these out. Oh, geez. I erased too much. Take these out. I'm going to erase them very carefully this time. Look what you're left with. You're left with a 2x plus 1. I'm going to put those back because I don't want to have my work erased. But you are left with a 2x plus 1. Color coding can help as well. And this is your factored form. So you're going to factor out the common parenthesis. Your second parenthesis is a combination, basically, of your GCFs. So if you take those out, what you're left with is that second parenthesis. Now let's compare that. I'm going to zoom in here to our original problem up here. If you see, our original problem was 2x plus 1 times x plus 3. I got those same exact parentheses here when I worked backwards. Remember, the order of your parentheses does not matter because the order of multiplication, even if you're multiplying parentheses, does not matter. The idea that 3 times 2 is the same as 2 times 3. Okay, let's do another example here. On this problem here, we are looking for 2 numbers that have a product of, two numbers that have a product of 3 times 2 and a sum of -7. So 3 times 2 is 6. So I'm looking for two numbers that have a product of 6, but this time I want their sum to be -7. So that means if we want a sum to be negative, we're going to have to work with negative values in our product. So we know that the way we multiply to 6 is 3 times 2, but I'll never be able to add those together even if the values were negative to get me -7. So now I'm thinking about 6 times 1. When I think about 6 times 1, if you add them together, you get +7. So the only way that you can get a +6 but have a sum that's negative is have two negative numbers. So -6 and -1 will give you +6, but when you add them together, you get -7. This is going to help us to split up our x terms. Okay, so let's look at this example here. So in this example, I'm going to draw a line down here. Okay, I'm going to bring down the 3x squared. Using these two numbers here is going to help me to split up my x term. It does not matter which one you put first. So it means I'm going to have a -6x and a -1x. These are your coefficients of your x terms when you split it up. Again, does not matter which one you do first. Don't forget to bring down the +2. In our next step, I'm going to go ahead and group my first terms together. I'm going to group my second terms together, and I'm going to put a plus sign in between. Look at the GCF, or look for the GCF of each group. The GCF of my first group is going to be 3x. I'm going to do the division in my head this time. If I divide out a 3x, I'll be left with an x here. If I divide out a 3x, I'll be left with a -2. Don't forget to bring down your plus sign. Now let's look for a GCF of the second group. So in this second group, the only thing that they really have in common is a 1. But we want our parentheses. If you only take out a 1, this is what's going to happen. You're going to be left with this. And that would make our two parentheses not be the same. Remember, what we want to happen, like on this last one, is we want those parentheses to be the same. So the way that we can make them the same is not just take out a 1, but take out a -1. I'll deal with that plus minus later. Okay? If I take out a -1, if I divide the first term by -1, I get x. If I divide this term, I get a -2. The way that you know to factor out a negative is, and I've mentioned this before, if the first term is negative, then the GCF is also negative. It's a good rule of thumb to go by when doing factor by grouping. So you can see here are my common parentheses. That's what they have in common. So I'm going to take that out. And then what you have left here is you're left with the 3x. And I'm not going to write it as plus -1 because plus a -1 is just -1. So make sure you write that in that simplified form. And you can see here that this is my answer. You can also check your answer really easily. Remember, the first terms should multiply together to give you the first term. The last terms should multiply to give you the last term. The way you should get the -7x is by checking this and this added together. So this product is -6x, this product is -1x, and you can see that I definitely get the -7x in the middle. You do not have to check it, but you definitely can. Okay? So I hope that this helped. Will do some more examples in another video, but these are examples I'm going to do. So if you wanted some more to practice and check with my video later, you can pause the video and write these down. Okay, so I hope that this helps. Remember that I do have another method of doing these problems. If you want to check that out, you can. It's called factoring trinomials, a not equal to 1, guess and check. And you sort of get a choice of which one works best for you. So if you like this video and some of my other videos, please subscribe to the channel so you can easily find my videos. And good luck with your practice.